Okay, folks, there's been some questions asked about this type of question, so I'm just going to go over what you need to do to actually get this question down pat. First of all, let's say that this is 10 kilograms. This is the information that you'd get to do this type of question. You need to extend this line up and down, okay? And like I was saying, if you take your set square, and you sit it on the ground, okay, from your geometry set, you're going to make sure you get a 90-degree angle. Okay, so I would advocate using the set square and a ruler, obviously, to get that to be 90 degrees, to make sure that you're more accurate than if you don't. Where it crosses is the point of concurrency, which you need to know. And like I was talking about when we were talking about three forces in equilibrium, that's where the third force is going to cross. They don't give you the third force. We know you've got a tension force happening here, and the force of reaction from the ground is the third force, and we know where it's going to go because it goes through that point of concurrency. Okay, and it's always a good idea just to extend this line down. Okay, and that'll become more obvious when we go further through the question. Then you need to take this tension line. So we know we've got weight acting down, and we've got a reaction force acting up from the ground, and we need to close our polygon to create a system of equilibrium because we have a zero resultant. Okay, so we can take this line here of tension and we can drag it down, and we have to keep it parallel. Okay, and if you don't know how to do that, you need to use a protractor to do that. But if you're uncertain how to do that successfully, let me know and I will show you how to do it. But it needs to be parallel. So you drag it down. So we now have our tension line completing our triangle. Okay, we know that that's 20 degrees. Okay, so the triangle that we're dealing with, you need to understand is, I'll just draw a box around it so that we understand what part of the diagram we're actually dealing with. The triangle that we want is this triangle here, okay? So it's not anything else, it's just this triangle. So make sure that you use that triangle. So the first thing you're going to do is you're going to get your protractor out, and you need to measure this angle here. Okay, so we're going to measure that angle, and we're going to say we got our protractor and we said that that was, say, 10 degrees. Then we're going to get a protractor and measure one of the other two angles, whichever one you think is easiest, but for this argument we'll go here, and we're going to say that is 100 degrees. Once we've got two angles, we just need to use the idea that there is 180 degrees is in all triangles. Okay, so if you say 100 plus 10 degrees, you get 110. So you say 180 minus 110 is going to be 70 degrees. So that's your final angle, 70 degrees there. So we can now use the fact that we know that this is 10 kilograms, so we know that this side of the triangle is going to be weight is equal to mass times acceleration. So it's going to be 10 kgs by 10 meters per second squared, the acceleration due to gravity. So the weight force is going to be 100 newtons. Okay, so we've got that down pat. Best deal now is to actually redraw your triangle so that it's clearer as to what's going on. So if you're going to use the sine rule to solve for the tension, because we're trying to find tension. Okay, you could also find the reaction force as well for this question, but we're just going to find tension. So to find tension, you need to say to yourself, let's draw this triangle again. So we've got weight equals 100 newtons acting straight down. Then you've got tension over here, which we don't know, which we're trying to find. And then we've got reaction force, force of reaction here. We know this angle is 70. We know this one's 100, and we know that this one is 10 degrees. So we can use the sine rule now. If you don't know the sine rule, watch the video before this one where I explain the sine rule. But basically what you need to do now is you just turn around and you say t, okay, which is a side that we don't know, over the angle that's opposite, so the sine of the angle that's opposite, so t over sine 10 degrees is equal to W over the angle that's opposite, which is 70 degrees, sine 70 degrees. So now we need to get rid of that, that sine 10 degrees. So we need to multiply both sides by sine 10 degrees. And when we do that, we end up with t, because it's sine, if we go sine 10 degrees here, it's going to cancel down. So we get t equals, we need to multiply this side by sine 10 degrees to keep the equation balanced. 10 degrees, sine 10 degrees over sine 70 degrees. Solve that and you'll get an answer that will be in newtons. So T will equal however many newtons that equals, and it will be, for the degrees, you just remember the tension was 20 degrees from the horizontal. I just might try and write that a little bit more neatly than that. So yeah. So yeah, when you do the direction, 20 degrees. Okay, because we in our original diagram, you can see in the original diagram that that was 20 degrees there. Okay, so that's how you do this type of question. You need to extend your lines. You need to find your angles, two of the angles, then subtract from 180 to find the third angle. Redraw it so it makes it more clear, and then solve for T. And if you wanted to, you could also solve for R as well. Okay, if you wanted to find the reaction force for this question, you could say FR, which we don't know, over sine of 100 degrees, which we do know, okay, is equal to, we know weight is 100 newtons, okay, over 70, sine 70. And we could solve for the reaction force as well. Anyway, hopefully that's helpful. Let me know if you've got any questions or comments, and also watch the sine rule video if you're unclear about the sine rule. Thank you.